So again, uh, so this is also coming under the forced vibration. See here, there is a engine. The engine is supported over a spring and dashpot. This is a ground. When the machine is connected like this, how the vibration will be in the machine? That's what we are going to discuss. The machine has a crank, a rotating crank. Say this is a some engine like IC engine. IC engine. IC engine has different parts like crank, connecting rod, piston. So here, in case of IC engine, there's a rotating part. The reciprocating part also will have a unbalanced force. Now, in this machine, we are considering only the unbalanced force created by the rotating mass. So the mass is m naught. The mass of the rotating crank is m naught. The total mass of the engine, total mass of the engine is m. Total mass of the engine is m. Within the engine, we have a crank that eccentricity is e. Eccentricity is e, and the mass of the crank is m naught. Mass of the crank is m naught. Now, since this is rotating with angular uniform angular velocity omega at any point time t, t, the angle is omega into t. At this point, what will be the vertical force? Since the support, these two are taking deflecting in vertical direction. So, what will be the force which is acting in vertical direction? Exciting force, forcing function. That will be centrifugal force into sine theta. That will be the vertical force. Centrifugal force into sine. What is the centrifugal force? M naught omega square E. This is centrifugal force, but it will be acting in various directions. But we are considering only the vertical force. Then m omega square E into sine omega t. So this is the forcing function. Already in the previous problem, we have taken forcing function is f naught sine omega t. F naught sine omega t. So in the place of f naught, here we have m naught omega square e. M naught omega square e. So this is the force sine into sine omega t. So this is a forcing function. This is a forcing function. So now, when this machine has a mass of m and forcing function of f naught m naught omega square e sine omega t. When this force is acting in this machine, how this will vibrate? How this will vibrate? Almost this is similar to the problem we discussed previous. So if you want to write the equation for that, the x is equal to what is x? It's the amplitude of vibration. X is equal to f naught by k. That was the equation. F naught by k. In the place of f naught, what do we have? M naught omega square e. This is f naught. F naught by k. F naught by k divided by root of 1 minus omega by omega n the whole square plus 2 into psi into omega by omega n the whole square. So this is the equation. Now you take the numerator. If you take the numerator, that is m naught omega square e divided by k. If you multiply denominator and numerator by mass, what is k by m? K by m is equal to omega n square. That is omega n is equal to root of k by m. So k by m is equal to omega n square. So here, if you take this, you can write it omega n square. And here we have a omega square. So you can write the equation like this: m naught E divided by m into omega by omega n square, the whole square. We can write the whole square, omega by omega the whole square. So this equation we can write again. The amplitude of vibration x is equal to m naught E divided by m omega by omega n the whole square divided by 1 minus omega by omega n the whole square plus 2 into psi into omega by omega n. So this is a equation. Similarly, we have equation for tan phi. Equation for tan phi. What is phi? This forcing the phase angle difference between this force angle function and the vibration. Right here, there are the vibration takes place along this direction, and this rotating mass will have a forcing function. The time or angle delay between this forcing function and the displacement, that is phi. So tan phi is equal to the same equation, 2 into psi into omega by omega n divided by 1 minus omega by omega n square. So this is the phase angle difference between the forcing function and the displacement function, right? So now you are going to solve a problem in this. Now a rotating machine have total mass of 20 kg. This is total mass, that is mass of the engine. So inside the engine there is eccentric mass, that is m naught is equal to 1.5 kg. The eccentricity is 25 millimeters. The machine rotates at 720 rpm. It is rotating at 720 rpm, which is 20 mm. Amplitude of vibration is 20 mm. X is equal to 20 mm. And the lag eccentric mass by 90 degree, that is phi is equal to 90 degree. So you got to find the natural frequency, damping factor, amplitude, and the phase angle when the rotation is 1440 rpm. So this is a given problem. Now let us see how to solve this. So in this problem, machine, the total mass is, that is m is equal to 20 kg, and the eccentric mass is 1.5 kg, that is m naught. So within this 20 kg, this m naught is there. M naught is rotating, that is 1.5 kg. Eccentricity E is equal to 25 millimeters. 25 millimeters. N is equal to, the machine rotates at 720 rpm. 720 rpm. Amplitude of vibration X is equal to 20 millimeters. 20 millimeters. And the phi, phase angle difference is 90 degree. So first step is you find the natural frequency. So in this problem, it is given that phi is equal to 90 degree. Then what is mean by phi is equal to 90 degree? Phase angle difference is 90 degree. Already we have discussed. See this graph, this is phase angle phi, this is frequency. When phase angle is equal to 90 degree, that is omega by omega n is equal to 1. When omega by omega n is equal to 1, the phase angle is 90 degree. Less than 1, the phase angle is less than 90 degree. Less than 90 degree. If omega by omega n is greater than 1, then when omega by omega n is greater than 1, then the phase angle is above 90 degree. So here we have one result. And the equation for phase angle also we have. So now we use this relation. Now we use this relation, that is tan phi is equal to what is the equation? 2 into psi omega by omega n divided by 1 minus omega by omega n the whole square. So this is a relation. Here tan phi is equal to 90 degree. Tan phi is equal to 90 degree. Then tan 90. What is tan 90? Tan 90 is equal to infinity. Tan 90 is equal to infinity. If this is infinity, what will be the value of this? This must be 0. If denominator is 0, then only this value will be infinity. So 1 minus omega by omega n the whole square. This is equal to 0. This is equal to 0. Then only this will be infinity. If this is equal to 0, then what is the meaning? 1 minus 1. Then omega by omega n is equal to 1. Omega by omega n is equal to 1. So that is what we can understand from this tan 90. That is phi is equal to 90 means omega by omega n is equal to 1. The same relation already we have seen in the form of graph. So now in this problem, what is the value of omega? Omega n is not given, but omega is given. But omega is not directly given. It is given in RPM. It is given in RPM. So this, what is this 720 RPM? That is, this crank is rotating at 720 RPM. So this is the forcing function. This is a forcing function. That that speed is equal to, that RPM is equal to 720 RPM. That is speed is equal to 720 RPM. That you have to calculate in terms of omega. So 720 divided by 720 is RPM. 720 is RPM. So divided by 60 if you put, that is equal to frequency. That is cycles per second, revolutions per second. So this is what F. So from this, if you want to find omega, that is 2 pi into F. That is equal to 2 into pi into 12. 2 into 5 into 12. That is equal to 75.39. 75.39. So already we know omega is equal to omega n. Omega is equal to omega n. So this is the value of omega. So that is equal to omega n. That is equal to omega n. So now we calculated omega n. What you have to find? You have to find natural circular frequency. So the first is over. That is omega n is equal to 75.39. Second one is damping factor. You have to find the damping factor. What is the equation to find the damping factor? Here in this problem, x is given. So now x can be written as x is equal to, what is the equation? M naught E divided by M into omega by omega n the whole square divided by root of 1 minus omega by omega n the whole square plus 2 into psi into omega by omega n. So this is the equation. In this problem, phi is equal to 90 degree. So omega is equal to omega n. What is the meaning? Resonance. That is, if omega by omega n is equal to 1, this term will be 0. And here, this will be 1. This will be 1. So you can rewrite here also omega by omega n. This is equal to 1. So you can rewrite the equation m naught E by m divided by 2 into psi. This is the equation. So here if you substitute, what is the value of x? X is equal to, in the problem it is given, it is 20 millimeter. We substitute in meter, so 0.02. What is the value of m naught? M naught is equal to 1.5 kg. 1.5 kg. So 1.5. What is eccentricity? Eccentricity is equal to 25 millimeters. So substitute in meter, 0.025 divided by m. M is equal to 20 kg divided by 2 into psi. So from this, you can find the value of psi. You can find the value of psi. So you can find the value of psi in this problem. Psi is equal to 0.046. 0.046. So you have calculated the natural frequency damping factor. Next is you find the amplitude of vibration. Already amplitude of vibration is given. This corresponds to what? That lagging, the phi is 90 degree. That is at resonance. At resonance, this is a amplitude of vibration. Again, you are asked to find the amplitude of vibration and phase angle at 1440 RPM. So now, so corresponding to this, what is the value of omega? You calculate. That is 2 pi n by 1400. So using this, you will be able to find the value of omega. So what is omega? Omega is equal to 150.79. 150.79. This is a omega value. Already we have the omega n value. It is 75. 75. So now you substitute in this equation. Substitute in this equation. You can find the value of displacement for 1440 RPM. So here m naught is equal to how much? M naught is equal to 1.5 into E is equal to 0.025 divided by m. M is equal to 20. M is equal to 20. Omega by omega n. Omega is equal to, in the new omega value is equal to how much? It is 150.79. 150.79 divided by, this is 75. This is 75.39 square divided by root of 1 minus omega by omega n. That is 150.79 divided by 75.39, the whole square, again square, plus 2 into psi. Psi is equal to 0.046 into 150.79 divided by 75.39, the whole square. The whole square. So what will be the value of x? X is equal to 2.49 millimeter. You will get in meters. So convert into millimeters. 2.49 millimeters. 49 millimeters. So this is a x value. Again, you have to find the value of phi, phase angle. So already we have the equation for phase angle, tan phi. Tan phi is equal to, this is a relation to find the value of tan phi. So tan phi is equal to 2 into psi, 0.046 multiplied by omega n. Omega is equal to 150.79 divided by 75.31 divided by 1 minus omega. 150.79 divided by 75.39, the whole square. The square. So using this, you can find the value of tan phi. If you find the value of tan phi, it is 176. It is 176.5 degrees. So natural frequency is 75.39. Damping factor is 0.046, and amplitude of vibration is 2.49, and the phase angle is 176.5. So this is a way you can solve this problem.